Alright, this is Math 111 OLC Winter 2012. My name is Carl Perez. Today we're going to talk about, within Unit 2. We're going to start Unit 2 with Section 2.2 in our text entitled Graphing Linear Equations. Alright, I'm going to assume from a first course in algebra that you all already know how to plot points in the XY plane. So I'm not going to review how to plot points. I'm just going to jump right in and talk about graphing linear equations or graphing lines. For example, first example, graph. If I ask you to graph the following equation, well, notice there's two variables in the equation, and there are infinitely many x and y values that will solve this equation. Well, they've got to correspond, of course, and what I can do is make a table of values first and find what ordered pair values, what corresponding x and y values will solve this equation. Well, notice y is solved for. In other words, y is given in terms of x. So in this case, I can really find an x value, and it may be a convenient x value, and then solve for the corresponding y value and get a list of coordinates that solve this equation. What I'm going to do is here, I notice I'm multiplying x by minus 1/2 in this equation, and if I pick my x values with a little finesse, I can bypass the unpleasantness of fractions, at least in this example. For example, if I pick x equals 0 and I solve for y, well, that's an easy matter here in this equation because 0 times anything is 0, and I get the corresponding value, y equals 3. So when x equals 0, y equals 3. Alright, let me pick another multiple of 2. Let's say minus 2. Alright, if I plug in that value for x, well, I know that minus 1/2 times minus 2 is going to give me positive 1. And, of course, 1 plus 3 is 4. So when x is minus 2 in this equation, y has to be 4. And again, let's pick another multiple of 2. When x is 2, I can solve for y hopefully easily. Oop, that's a 3 there. So 2 times minus 1/2 is, of course, negative 1, and negative 1 plus 3 is positive 2, right? So using this table of values here, 3 points is plenty. I can graph this line equation. Now I want to put this on the same screen here, so let me erase all this previous work here. I'm going to do my best to draw a coordinate axis, the XY plane, and graph these points. And give me a minute here. Of course, doing homework on graph paper will make things a great deal easier for you. Alright, so let me graph these 3 points. When x is minus 2, y is positive 4. Alright, so that puts me about here in the xy plane. Oh, I really should label these axes, of course. If x is 0, y is 3. And there's a special name for that point. That's called the Y Intercept, for obvious reasons. When x is 0, you're always on the y-axis somewhere. Alright, and the next point here is x is 2, y is 2. 1, 2, 1, 2 puts me here. Alright, so that looks okay. It's not too crazy to claim that all these points are collinear, that they land on the same line. And if I label this line with the equation that generates it, I've got a satisfactory graph of this linear equation. Alright, now 2 points determine a line, So technically 2 points are enough to graph a line equation. We usually look for a third point, and just to confirm, sometimes we may have made a mistake and we won't really know until we actually graph these points. Okay? So let me make a note here. All points on this line solve the equation y equals minus 1/2 x plus 3. Right, we've only listed 3 of them. There's infinitely many x and y corresponding values that will solve this equation. So really this graph is the solution set for the equation y equals minus 1/2 x plus 3. All right, let's do another one. And 1/3 x plus 1. Again, it's convenient that y is solved for. In other words, y is given in this equation in terms of x. It doesn't always so happen. Again, I'll make a table of values. And if I pick my x values with a little finesse, I could make my life easier here. Let's say if x is 0, well, a third times 0 is 0, and then y must be 1 to be on this line. Okay? So the point 0, 1 solves this equation, right? Well, let's pick another multiple of 3. For example, minus 3 is a multiple of 3. If x is minus 3, let me write this down. I can easily solve for the corresponding y. A third times minus 3 is minus 1, and minus 1 plus 1 is 0. So when x is minus 3, y is 0. And similarly, when y is 3, well, I'll do this in my head, 3 times a third is going to be 1, and 1 plus 1 is 2. So I can easily graph this line equation now. When x is minus 3, y is 0. Right? Special name for that point, this is called the X Intercept. When y is 0, you must be on the x-axis somewhere. Right? So we call this point the X Intercept because, of course, this is where the line is going to intersect the x-axis. When x is 0, y is 1. Oh, of course, when x is 0, you're on the y-axis somewhere. This point, this pair of coordinates, is called the y-intercept. And when x is 3, 1, 2, 3, y is 2, 1, 2, puts me here somewhere. All right, there's a third confirming point there. All right, so I'll connect the dots here. Do the best I can freehand. All right, so there is the graph y equals 1/3 x plus 1. All right, so 3 points. Label the graph with the equation that generates it, and again note that all the solutions of this equation y equals 1/3 x plus 1 lie on this line somewhere. Okay? Alright, let's try another one here that may not be so conveniently listed for us. If I ask you to graph 2x minus 5y equals 10, the book asks us to use the intercepts in one of the examples in our text in this section 2.2 to graph this line equation. Alright, well, every x corresponds to some y on this line, every y corresponds to some x on this line. The idea is to find some convenient values to graph. 2 points determine a line, so if I can find these 2 intercepts, x and y intercepts, I should be okay in graphing the line equation. Alright, when x is 0, what's y? Well, I can easily plug in 0 for x and solve for y. So 2 times 0 is 0, and I get minus 5y equals 10. and y equals I will equal a minus 2, right? So I claim 0 minus 2 is a solution to this linear equation. Hence, it must fall on the line, the graph of the solution set for this equation. Let's try the y-intercept, or I'm sorry, the x-intercept, when x is 0. Let's see. Slipped a little bit. When y is 0, let me plug 0 in for y and see if I can solve for x. Of course, 5 times 0 is 0. I'm left with the resulting equation in x. 2x equals 10. Of course, x then equals 5. Alright, so these are the two intercepts. This is the y-intercept, because I know when x is 0, this is where the line is going to intersect the y-axis. Similarly, the second point is the x-intercept. When y is 0, I'm going to hit the x-axis at x equals 5, so I can go ahead and graph this line equation. Try and squeeze it in here. When x is 0, y is minus 2. All right, puts me 2 units south of the x-axis on the y-axis, of course. All right, when y is 0, x is 5. Alright, so there is my x-intercept. Alright, I'm going to go ahead and connect the dots. It's a line, believe it or not. And the best I can here freehand. Alright, so this line is the graph of the solution set of the equation 2x minus 5y equals 10. So when you graph the equations, label the x and y axes, label the line with the graph that generates it, and of course put arrows on the ends of the lines to indicate what they call the end behavior of the line. The arrows just indicate the solution set for this equation goes on forever. There's infinitely many solution pairs for this equation, and they all fall on the same line. Alright, let's try something like graph, something like this. Graph y equals minus 3. Well, you'll notice there is no x in this equation. Well, the graph of it is still a line. In theory, if we make a table of values for this equation, well, the idea y is minus 3, always minus 3. Notice x doesn't even appear on this in this equation, so x can be any value in the xy plane, and it will, as long as we have the value y equals minus 3, it will solve this equation. Well, the idea here is if I show coordinate axes with all points with the y-coordinate minus 3, well, y equals minus 3, the y-intercept of minus 3 is down here somewhere. It's really a horizontal line. In other words, y is constant. Y never changes in this equation, so no matter what x is, y will always have a value of minus 3. So this is a horizontal line with a y-intercept equal to minus 3. And I think you can appreciate this will happen not necessarily just with minus 3. The graph of anything of this form, where y equals a constant, is a horizontal line. Alright, so y equals constant, horizontal line. Alright. How about graphing something that looks like this. X equals -4. I think you might know where we're headed here. If I make a table of values here, notice y doesn't even appear in this equation. X is always going to be -4, -4, -4, no matter what y is. Y can be anything. X will always be a constant -4. What's going to happen in that situation? Alright, well, let's see. -1, -2, -3, -4. Basically, I'm asking for the set of points in the xy plane that have an x-coordinate of -4. Well, x never changes in this equation. X is always -4. X is constant at -4. Well, y will never y can be anything, and x will always be a constant -4. Alright? Alright, nothing sacred about -4 either. So if I graph anything of the form x equals a constant, be it -4 or any other value, you'll always get a vertical line. Alright, so y equals constant, horizontal line, x equals constant, a vertical line. Alright, let's graph some other things. How about this? And this is a line equation in what we call standard form. If you are, write this down, if your line equation is in this form, ax plus by equals c, in other words, you've got some multiple of x plus some multiple of y equals a constant, this is what they call standard form of a line equation. Alright, if we see that a here, cap A would be 1, 2 plays the role of b, and c would be a -2 in this equation, clearly we are in standard form here. Alright, how we're going to do this is construct a table of values. When x is something, y is something. Well, let's see. When x is, let's see, can I use maybe a guess and check method? Let's experiment. And again, it's a trial and error process at this point in the chapter. If x is 0, well, I think we can all see if x is 0, then 2y equals -2, and y must be equal -1. Okay, so there's 1 point. Again, I'm going to try to shoot for 3 points here. If x is, let's see, I think I see another one here. Let me erase this work here. I'm going to try x equals -2. I think I see something happening. -2 plus 2y equals -2, so 2y equals 0. And if 2y equals 0, that of course means y equals 0. So when x is -2, y equals 0. Of course, if you can do this work in your head, so much the better. Let me erase this side work because I want to leave room for the graph. And let's try another one. Let's say x equals +2. Let's say if x equals +2, I can then solve for y. So let's see. I'll then subtract subtract 2 from both sides and get 2y equals -4. I'll only fill this in. When x is 2, I'm substituting 2 for x in this above equation. So 2y equals -4 then, subtracting 2 from both sides. And y, of course, equals -2, dividing both sides by 2. Alright, so there are 3 nice points, convenient points, which I hopefully can graph without too much trouble. Let me take a minute. If x is 0, y is minus 1. That is the y-intercept. How do I know it's the y-intercept? Because x is 0. The x-coordinate is 0, meaning I'm on the y-axis somewhere. If x is minus 2, y is 0. This is the x-intercept, because when y is 0, you must be intersecting the x-axis somewhere. Here it's at minus 2. And if x is 2, y is minus 2. It puts me here. So it looks reasonable to claim that these 3 points are collinear. I don't think I've made a mistake. Sketch a graph. And very important to label the line with the equation that generates it. And again, all solutions to this equation, x plus 2y equals minus 2, are indicated by this line, or the coordinates of the points on this line. Okay? Alright, we've largely kept ourselves conveniently free of fractions here, but we won't always be so fortunate. Let me give you an example of what I'm talking about. Graph 3x equals 4y minus 11. This is from the homework list, and the author asks us to graph this linear equation using intercepts. Alright. Well, I get a little nervous when I see this because I see 11s and 4s and 3s, and I think there's no way around it that I'm going to end up with fractional values for my intercepts, and that can happen sometimes. So let's do our best in sketching the graph by hand to deal with some fractional coordinate values. All right. Make a table of values here. We want to use the intercepts. Again, the author tells us to use the intercepts here to graph this equation. Alright, well, that means I'm going to have to find the y-intercept and the x-intercept. If I let x be 0, I can easily solve for y. Let me do some side work here. Right. So 3 times 0 equals 4y minus 11. Well, 3 times 0, of course, equals 0. If I add 11 here to both sides, I get 4y equals 11. And dividing both sides by 4, I get y equals 11 fourths. Alright, don't panic. We've got a fractional value to graph here. We'll do our best. 11 fourths. We'll put it down in the list, and we'll deal with that in a minute. Alright, that's the y-intercept. Let's look at the x-intercept now. Well, if I'm looking to find the x-intercept, I'm going to let y be 0. Right. So 3x equals 4 times 0 minus 11. I'll substitute y equals 0 in the given equation. And 4 times 0 is 0. So 3x equals minus 11. And x equals minus 11 thirds. Alright, don't panic. Yes, it is a fraction. It's a negative fraction. We'll have to deal with it in our graph. Alright. Alright, let me erase this and we'll quickly sketch our graph. Now, ordinarily I'd like to get 3 points, but the book instructs us to just use the intercepts, so we'll obey. Now, 11 fourths. Where is 11 fourths on the real number line? Well, 12 fourths is 3, right? So 11 fourths is just going to be a little bit shy of 3 on the number line. All right, so when x is 0, y is 11 fourths, somewhere a little bit shy of positive 3 on the y-axis. Alright, so I'll do the best I can to indicate that fractional coordinate value on the y-axis. What about when y is 0? When y is 0, well, I'm on the x-axis, minus 11 thirds. Well, what's minus 12 thirds is equivalent to minus 4, so we're not quite at minus 4. We're actually a third to the right of minus 4 on the x-axis. So again, minus 4 puts me about here, and I'll just graph my x-intercept a little bit shy of minus 4 on the x-axis. So when you've got fractional coordinates, easier to do when you've got graph paper, but we'll just do the best we can and label the line with the equation that generates it. So there is a graph of that line equation using the x and y intercepts. Oh, by the way, this is the y-intercept here, and this pair of coordinates represents, of course, the x-intercept. Alright, I want to do one more before we call it a day in this section and get another layer. How about, this is from the homework list too, I believe. Now, you're always not given equations in nice, neat form. Sometimes you gotta sweat a little to get things in convenient fashion. Alright, notice this is not in standard form, and y is not solved for, so we're gonna have to struggle a little bit. Again, to graph a line equation, at least at this point in the game, we're going to make a table of values, hopefully containing 3 collinear coordinate pairs that when graphed will illustrate a line. Alright, we've got to find corresponding x and y values, and I've got a little trouble looking at this and spotting it, at least by inspection. What I'm going to do, I'm going to transfer things around a little bit. I'm going to add 2y and 3x to both sides and get this equivalent equation. Alright, if I add 3x to both sides and simultaneously add 2y to both sides, I get this resulting equivalent equation. 9 equals 3x plus 2y, and this is in standard form. Alright, and I think I can see maybe a little more clearly now where I can get some pairwise values for x and y that will solve this equation. Right away I see when x is 0, when y is 0, x has to be 3. Alright, so there's a convenient point right there. Let's see, I'm going to try my best to not get fractional values to deal with here. Notice if I let x be 0, y is going to be a fraction. So I'm going to try to stay away from that. I think I see something here. If x is 1, right, then if y is 3, that'll solve this equation, right? 3 times 1 is 3. 2 times 3 is 6, and 3 plus 6 is 9. That solves the equation. So when x is 1, y is 3. That solves this equation. And I think I see another one here. Let's see. If x is minus 1, let's try that. What can y be? Well, I think if y is 6, that'll solve this equation, right? Because I know that 6 times 2 is 12, minus 3 is 9, and that solves that equation also. Alright, so with a little detective work, I can come up with 3 coordinate pairs that solve this equation. So now I'm going to graph these in the xy plane. When x is 3, y is 0. That's the X Intercept. When x is 1, y is 3. See there. When x is minus 1, y is 6. 1, 2, 3, 4, 5, 6. Puts me up here somewhere. Alright, and it looks like these points are collinear. Doesn't look like I made a mistake here. I'll connect the dots with a line indicating all the solutions of this equation fall on the same line, and I'll label the line with the equation that generated those three coordinate values. Okay? Alright, that brings to close this section 2.2. We are at the 31-minute point. So this concludes section 2.2, and please be sure to review all homework problems and their solutions before you attempt the online exam. That is all.